Spend a ton of time. We covered this yesterday. I'm going to refresh your memory. In the unit circle that we talked about memorizing, they only use two triangles. 45, 45, 90 triangle called the isosceles right triangle and the 30, 60, 90 triangle. An example of each would look like this. On the left, I could have maybe a 7, and a 7 square root of 2. What I want you to notice in this triangle is that when you're going from the leg to the hypotenuse, you are multiplying by the square root of 2. When you're going from the hypotenuse to the leg, you're dividing by the square root of 2. That's what happens in the 45, 45, 90 triangles. In the 30, 60, 90 triangle, on the other hand, if I look at that one, I could pick some numbers like, for example, maybe 5, 10, and 5 square root of 3. If we look at some rules, I guess, some easy rules to work with, if I'm going from the short leg to the hypotenuse, I'm going to use small, medium, and large, I guess. From the small side to the hypotenuse, I'm going to go with multiply by 2. From the hypotenuse to the small side, I'm going to divide by 2. And then from the small side to the medium side, I'm multiplying by the square root of 3. And from the medium side to the small side, I'm dividing by the square root of 3. And I don't really go from the medium to the hypotenuse because I can always find an alternate route to get there. So how I talked about my strategies and what I do, I don't ever memorize those rules. I just memorize actually small to hypotenuse and small to medium, and then I know how to do the reverse. Sometimes people forget which one has a square root of 3, square root of 2. This is not actually mathematically accurate, but the statement I'm going to make helps me remember which one's which. In the 45, 45, 90 triangle, there are only two different size angles in that triangle. That's why we use the square root of 2. In the 30, 60, 90, there are 3 different angles. That's why we use the square root of 3. That's a false mathematical statement, but I've never forgotten it. So I always know which one to use. So if that helps you, great. If not, whatever. Okay, looking at your unit circle. 30 degrees is the same as pi over 6. You guys see that on your unit circle? Right? Yeah. All right. Now, what I want to show you from that hand trick yesterday and the bent finger, the sine, we learned that the sine is really the same thing as the y value in our ordered pairs. Remember we talked about how x and y were now going to be called cosine and sine. Do you remember that? In case you don't, you can go back and look at your notes because I'm sure you have them there. Notice how x comma y is alphabetical, so is cosine sine. C comes before s. So if you can't remember, it's alphabetical. That's how I remember it. So the x value is really like the cosine in your ordered pairs. The y value is really like your sine. So as I write these down, that means that the sine is y, the cosine is x, the tangent is sine over cosine, or in other words, the y over the x. And the next three are the flips, the cofunctions. So like cotangent is the flip of the tangent, so this one's x over y. The secant is the flip of the cosine. Oh man, cosine's not over something.
1 over x.
So it's 1 over x. Very good, Joe. And then the cosecant, of course, means that would be 1 over y. Look at your unit circle. Look at the 30-degree angle. What's the y-coordinate of the 30-degree angle?
Square root of 3 over 2.
No.
1 over 2.
1/2. You know how I know that? Pi over 6. 2, 3, 4, 6. Sine is the y value, square root of 1 over 2. 1/2. That means the cosine is the other one. Square root of 3 over 2. The tangent is the y over the x. Remember the comma, like an ordered pair?
Yeah.
See it? Okay, the y value is 1. The x value is a
3.
3. They both have square roots. So it's y value 1 over 3 value. The square root of 1 is 1. The square root of 3 is square root of 3. I can't do anything with it. But I have to rationalize it. So you bring the root 3 up to the top, multiply by the square root of 1, which is 1, and put the 3 on the bottom. And then to find all the other ones, you just flip them upside down. Later on, we're going to kind of understand what cofunctions mean. It stands for something being out of phase. I don't really want you to worry about the stuff that you see right here too much. It's not really going to have a big impact on you during this part of Chapter 4, but when we start Term 2, it will, and I'll talk more about being out of phase by pi over 2. And then the other things that you see here on this slide are things that you have to remember. I just got done talking about when we were doing these trig pieces in the table, or part of them, that the tangent was the sine over the cosine. There are the reciprocal identities, which we already talked about. That means you flip the fraction upside down, or 1 over in other words. So sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. Tangent and cotangent. And then you could write them the other way if you want to. And the 1 over basically means flip the fraction upside down. That's all it's saying. Flip the fraction upside down. The cool thing is that in the Pythagorean identity, when you look at it, this is the most famous trig identity. Sine squared plus cosine squared equals 1. From that, you can get anything. So let me show you what that means. Sine squared plus cosine equals 1. Do you remember our unit circle that we got done working with? All right? And we talked about how there were special right triangles in that unit circle. So if I drew my circle, here's my unit circle, and I said, hey, let's look at one of those triangles. Let's pick the 30, 60, 90 triangle, the one that went like this, and the angle right here was 30 degrees, and there was the 90 degree angle over here, and then there was the 60 degree angle over here, and this coordinate right here was pi over 6 coordinates, which we just got done talking about again. And those coordinates were the square root of 3 over 2 and 1/2. And what's the hypotenuse on the unit circle?
1.
1. That's why they call it the unit circle. Unit 1. So if I look at what this is saying, we have to remember that the sine is talking about the y value, the cosine is talking about the x value. And really what this is saying is the y squared plus the x squared equals the radius squared. Pythagorean theorem. A squared plus b squared equals c squared. Look at the blue triangle. The horizontal distance, which is the cosine x, is root 3 over 2. So I have a squared plus b squared equals c squared. The c is the hypotenuse, which is 1. The b is the y value, which is the same as the sine being squared, which is 1/2. And the x was root 3 over 2, because that's the cosine. So root 3 squared is 3. 2 on the bottom squared is 4. Plus 1 on the top of the next fraction squared is 1. 2 on the bottom squared is 4. And 1 squared is 1. 3/4 plus 1/4 is 1. So that's what all these things mean. They're talking about the right special right triangles inside of our unit circles, in case you care. Okay? So that's what all of these are. So you can memorize them. The most important one is the one in pink. You can actually, from that pink one, get anything. All right, let's look at something kind of important that you need to recognize. As you look at your unit circle, take a look. When I talk about the sine part of a coordinate, which part is that?
Y.
If you can't answer that within 2 seconds, you're in trouble. No crap.
Sine part of coordinate.
X and Y is now called cosine sine. So the sine part is the same as the y value. and the x is the cosine. You better know that. No joke. Look on your unit circle and tell me where is the sign. Sorry, let me rephrase. Which quadrants are positive for sine?
1 and 2.
Yeah? 1 and 2 is correct because that's where the y values are above the x-axis. Okay? For the cosine, it's 1 and 4. With me so far? All right. What about for the tangent? No.
1 and 3.
1 and 3.